You have probably seen them on many devices, including household appliances. This kind of motor is everywhere. Sometimes we can also find them inside toys, like this one. These are DC motors, which are powered by DC voltage or a battery. And the motor in my hand is also a DC motor. On the other hand, we have an AC motor, which works with alternating current. Alternating current works in a sine wave. Here, in this wave animation, it starts from 0, goes to the first positive peak, then back to 0, and then to the negative peak. This completes a cycle of 360 degrees. Later, we will explain it when we discuss the alternator. Now I will focus on the AC motor. In this video, we will learn more about the AC motor's structure and working function. A AC motor is a type of electric motor. It is a device that converts electrical energy into mechanical energy, producing rotational motion. You've probably seen them on many devices. To understand mechanical energy, here's an example for you. In this example, the motor, along with the gear assembly, is used to turn the wheel assembly. This is a mechanical process. AC motors can be further categorized by the number of electrical phases they use, with single-phase AC motors and three-phase AC motors. Here, single-phase doesn't mean just a single wire. Normally, we notice two wires, right? One wire carries the alternating current, AC, which is the phase wire, and the other wire is the neutral wire, which provides a return path for the current to complete the circuit. Three-phase AC motors use three-phase wires, while single-phase motors use one-phase wire along with a neutral wire. If we open one up, we will see several key components. First, this is a rotor, and it is fixed with a shaft. The rotor is the part that spins, and the shaft is the component through which that rotational movement is transferred. This is the most common type of rotor. It consists of a cylindrical laminated steel core with conductive bars, usually aluminum or copper, embedded in slots along its periphery. These bars are short-circuited at both ends by conductive end rings, forming a cage-like structure. This is called the squirrel cage rotor. Next, inside this housing, this is the stationary part of an AC motor. It plays a crucial role in producing the rotating magnetic field that interacts with the rotor to generate torque. The stator consists of two main components, the stator core and the stator winding. The stator core is typically made of laminated silicon steel. These laminations are thin sheets of steel insulated from each other and stacked together to form a cylindrical structure. The stator winding consists of insulated copper or aluminum wires wound into coils and placed within the slots of the stator core. This footage showcases an automatic stator winding process. At the rear, additionally, a fan is installed for the cooling system. This is bearing. This deep groove ball bearings are very common due to their versatility, ability to handle both radial and moderate axial loads. Now, if you open this AC motor, you will never see a commutator, but in a DC motor, you will see one. In the DC motor, power is transmitted through the commutator, and within the armature, it generates an electromagnet, causing the rotor to rotate. You can watch how the DC motor works from the above link. However, an AC motor works based on a rotating magnetic field. The power is connected to the stator winding, which then generates a rotating magnetic field, causing the rotor to rotate. In the next video, we will explain more about the motor's working function. But until then, if you like our video, share your comments. Thank you.